Yes, very good evening, my dear students and all the respected dignitaries who are watching this video. This is part 2 of my subject, which is electric circuits or network analysis, we say. Just day before yesterday, part 1 is about preparation strategy. What is about my subject, the syllabus, the material, etc. we discussed. Now this is directly talking about my subject alone. But still, in continuation to what we did discuss on Saturday, and all these videos are always available in YouTube. Please subscribe to our ESE Engineering Academy and ESE online channel. Pause it and see some important details, because these slides are not prepared just for fun. Let me tell you, sir, lot of effort, lot of data analysis and content has been pulled. So please take your time to understand the meaning of GATE exam, ESE exam, Genco Transco, and the pattern, the syllabus, and the style of attacking the exam. But today, yes, we will be concentrating pure on important questions and concepts. It is not just important, but important concepts. Like what does my subject deal with, what type of questions come, and how to tackle them, 2 marks, MCQ, NAT, MSQ, we will discuss that in detail. Yes, myself, I am B.S. Krishnavarma, one of the faculty, yes, senior faculty I would claim now, in ESE Engineering Academy and ESE Online. I deal with this subject and most experienced in this subject, okay? Though as electrical engineer, we learn a lot of subjects, but this subject I am very confident. That is the only thing I can claim. Yes, this is electric circuits or network analysis, okay? Electrical people will call electric circuits and ECE networks, because difference in frequency domain, application part. At power level, closed path, transfer of energy, circuit concepts are important for electrical. But ECE people at signal level, wireless communication, data communication, okay, mobile communication, Bluetooth, radar, sonar, network concepts there. So that is how, sir, electrical are transporting this energy at power level with closed path conductors. So circuit concepts are important for electrical. ECE at signal level, ECE at signal level, electrical at power level. ECE at signal level are transporting this energy at signal level. So for them, wireless communication, Bluetooth, that is network concept. Like 2 cell phones together form a network, but each cell phone is a separate circuit, but together they are connected as a network. Airtel is a network or circuit? Airtel is a network. Vodafone is a network. Each cell phone is a sub-circuit. So that is the difference between network and circuit, application difference. But when it comes to analysis, again mesh and nodal, Thevenin's theorem, Norton's theorem, that is all same. But they study at power level circuit concepts, EEE people. ECE study signal level network concepts, application difference, okay? They may have amperes and kiloamperes, they may have milli and microamperes. Analysis concepts are same, but power level versus signal level. And application difference is the only thing, sir, okay? But only as far as syllabus is concerned, electrical people, remember, you have 3-phase analysis. That is the only difference. But when it comes to ECE people, you don't have 3-phase, you have only single-phase AC circuit analysis. But when you are attempting ESE, IES we call ESE, there 3-phase is also required. So for ECE students, 3-phase is there in IES. Basics, of course, balanced 3-phase system. But electrical, you know, 3-phase, you study like anything, unbalanced, balanced power system, symmetrical component. That is the only difference. Otherwise, 99% everything is same. Okay? Power level, signal level, 3-phase extra, 3-phase is not there for them. That's it. Then, yes, when it comes to my subject, I divide my subject into 3 major areas. DC steady state analysis, AC steady state analysis, and transients. What is that? Briefly, I want to discuss. But to do AC steady state and time variance concepts are necessary. Because in ideal DC, which I will discuss now, in ideal DC, our elements are behaving different way. The fundamental 3 passive properties, that is RLC, and AC they behave. But before we go to frequency domain AC circuit, here a small chapter I will introduce in my regular class about basics of time variance. This is where I will introduce LNC. So what I want to argue, yes, my subject is primarily divided into 3 parts. Part 1, DC steady state analysis, somewhere around 30 to 40%. AC steady state, this is also 30 to 40% based on the marks. And remaining, okay, remaining I will say, okay, yeah, I can say something like 30 to 20% is transients and miscellaneous topics like two ports, locus diagram, dual duality. So overall my subject is 3 parts, DC state. Now let us talk something important. Now what is ideal DC steady state analysis? Now in the first part of my subject, we assume ideal DC signal. What is ideal DC? Ideal DC signal is a signal which doesn't vary in time, and as a source it can supply energy up to infinity. But here dV by dt and di by dt's are 0. So in ideal DC, yes, dV by dt and di by dt's are 0. Do you have ideal DC signal? Tell me everybody, do you have ideal DC signal? Ideal DC signal is not everywhere, but a new battery up to first few hours before discharging or first few minutes is like ideal DC. And also function generators at electronic level also ideal DC. You know this IC cell like 78XX series, 7805, 7812, they are voltage regulator ICs. When you do a microcontroller project or electronic project, electronic level, this voltage regulator ICs are almost ideal DC. In your labs also function generator is there, na sir? Use first set of 5 volts or 15 volts in an op-amp circuit. That is almost ideal DC. So where is ideal DC? Ideal DC is not everywhere. Ideal DC is not everywhere, but we can model certain limited applications as ideal DC, like a new cell or a battery for first few minutes or first few hours before discharging is ideal DC. And function generator or integrated circuit voltage regulator IC set electronic level are ideal DC. But when it comes to practical, like your rectifiers, DC-DC converters, switched mode power supply, they are all practical DCs. So in my subject, as a network theory or circuit teacher, we assume first ideal DC circuit. Practical DC, power electronics are, analogs are, signals are will teach. I don't teach. So what I teach ideal DC circuit analysis. Okay, now for ideal DC, we know dV by dt and di by dt are 0. Okay, there is no rate of change of voltage and there is no rate of change of current. And when I give ideal DC to our circuit components, yes, resistor is homogeneous and proportional. Homogeneous and proportional, it is a linear component. Like DC voltage will give DC current. But a pure inductor acts like short circuit and a pure capacitor acts like open circuit. So when I give ideal DC to my circuits, resistor is a homogeneous proportional component, but inductor acts like short circuit, capacitor acts like open circuit. So that means only resistive networks we are going to study. So the first part of my subject, only resistor will come into picture. Of course, independent, dependent source, etc. we study, but only resistor we are going to focus on. Okay? That is why in the first segment of my subject, you won't see inductor capacitor because we are assuming ideal DC. In ideal DC, dV by dt and di by dt 0, inductor voltage across it is 0, short circuit, capacitor current through it is 0, open circuit. So only resistor is the element which is homogeneous and proportional. All the concepts with resistor only we do. And it is very easy, simple, easy calculations. No phasor, no calculator is required. So that is a thing. But in exams like IES and GENCO, sometimes 40 to 50% bits come from DC only. That is why don't underestimate, sir. DC may be easy, but why to neglect easy things? If you want good rank, it is not about being special in any area. It is about covering all the topics and score maximum marks. Don't ever do that by being specialist in any area. All are equal, all are important, but in fact, that areas where more bits and more marks and easy scoring, concentrate more. I know easy, DC is easy, but in GENCO, Transco where calculator is not allowed, IES also calculator not allowed, sometimes 40 to 50% bits come only from DC circuit analysis. So don't underestimate. Okay, chalo. So the first part is ideal DC. So where is ideal DC? A new cell or a battery or a function generator. Practical rectifiers, DC-DC converters, etc. Power electronics are, signals are, and analogs are will teach. But I would also conclude saying that ideal DC ripple factor is 0. There is no ripple. Ideal DC ripple factor is 0. So no filters are required. That is the first part of my subject. So purely resistive circuit. Inductor short, capacitor open. Then before I go to AC steady state, we will talk something about, yes, basics of time variance. That means in this small chapter in my detailed analysis when I do in my class or even online, I first give time varying signals. So though here we discussed ideal DC, but this time what I will do, I will give time varying signal like a triangular waveform. Okay, like a sawtooth waveform. Okay, like today, you know, square waveform. Okay. Now these signals are neither pure DC nor pure AC. That is the language I use. I say these signals are neither pure DC nor pure AC. Like here, okay, it is AC but not ideal AC because ideal AC is sinusoid only. Ideal AC is sinusoid only. It is an AC triangular but not ideal AC. Okay, ideal AC is sinusoid. There is a big reason which I will tell you. And this is DC but not ideal DC. This is DC but not ideal DC. Its average value is what I want. That is the DC component. Its average value is the DC component I use, but it has got lot of harmonics when you expand with Fourier series. And this is AC, again not ideal AC. It is AC but not ideal. But our inverter, single phase inverter, etc. give this only. Okay? Sinusoidal inverters with PWM control techniques are very costly, but still ideal AC never an inverter can give. Today multi-level inverters, matrix level inverters came, but no inverter can give ideal AC sinusoid. So in this chapter, before I go to ideal AC steady state, I want to introduce basics of time variance. Now what happens? Here again resistor is a homogeneous and proportional component. That means resistor is independent of frequency, it will still work the same. That means triangular voltage give triangular current, sawtooth voltage give sawtooth current, square voltage square current. Resistor is not issue, but inductors, capacitors are different, because in inductor V is L di by dt or I is 1 by L integral V dt. This is the Ohm's law for inductor. Similarly capacitor, I is C dV by dt or yes, V is 1 by C integral I dt. That is how we learn. For example, if this voltage is given to inductor, what is the current shape? Chalo, if this voltage, think sir, if this voltage, I will assume this is a voltage. If this voltage is given to an inductor, what is the current shape? If this voltage is given to inductor, now see here, yes, current is 1 by L integral V. If this voltage is given to inductor, what is the shape of the current? Now integration of voltage. That means 0 to some this time, 0 to some this time, it is a ramp voltage. Integration of ramp become parabolic current, parabolic. Understood? Suppose same thing. If this voltage is given to capacitor, if this voltage is given to, what is the shape of the current? I is C dV by. Differentiation of ramp, step will come. So that means if this voltage is given to inductor, current is parabolic, but if this voltage is given to capacitor, current is step. That is how analysis will start. So more rigorous mathematical analysis will be done in this chapter called Basics of Time Variance, where we will focus more on inductors and capacitors. Here resistor is very simple, L and C are, this is short and open, but here all are working. We use. Similarly in a capacitor also, see capacitor also I can say, suppose if this is the current given to inductor, ulta, if this is the current given to inductor, what voltage will come? When there is no change, inductor acts like short circuit. But when there is a sudden change, impulse voltage will come. So it acts like impulse voltage generator. So that is a very interesting chapter, sir, but very important. But that analysis, what I do for chapter number 4 in my theory subject and practice, will be so useful for your power electronics, signals, analog, etc. But this is neither pure DC nor pure AC, but we will introduce carefully L and C components. Okay? But resistor, no need to specially study in this chapter. The reason, it is still homogeneous proportional. Now after learning basics of time variance and especially inductor capacitor, sir, now we will go to ideal AC steady state analysis. Ideal AC is sinusoid. Ideal AC is sinusoid. Sinusoid. Yes, ideal AC side. Though I can say, see, though this is also triangular AC, square AC, but ideal AC is only sinusoid. Sinusoid means it can be sine wave or cosine wave, sir. What is the meaning of sinusoid? Either Vm sin omega t or Vm cos omega t. This is the number one AC waveform. What is the reason? The reason is very simple. The best waveform in electrical power engineering to generate, transport and distribute our electrical energy bulk level with minimum losses and highest efficiency is only possible with sinusoid. That is where the fight happened between Edison and Tesla. This is what I was giving a hint in the last class. See, Edison initially told that DC is the best waveform. But our energy cannot be transported with DC everywhere because DC cannot be stepped up or stepped down. Later, Tesla came and proved that this is the best waveform with which we can transport our energy to long distance by stepping up, stepping down, where transformer is the heart of our power system. Transformer is the heart of our power system. So that is why electrical people, yes, for them, the number one waveform at power level is which waveform? AC. At signal level, number one waveform, DC. At power level, number one waveform, AC. Like, give me examples, sir, in your house. Tell me which applications are running with DC and which applications are running with AC. watches, cell phones, yes or no, watches, cell phones, battery, torch, this is a remote control, they are all DC, portable, compact, yes or no, precision, accurate, these are the features of DC. So DC features are precision, accurate, portable, compact, etc. But they are not powerful, okay. You can do wireless transfer of power, but that is few watts. Don't ever talk megawatts, gigawatts. Wireless transfer is only few watts, milliwatts. But when you are talking about bulk level, okay, yes, that is where AC. Now tell me which applications in your house are running with AC steady state? Fan, heater, motor, okay, so no, lift motor, pump motor, they are all induction motors. That is where AC is the winner. So at bulk level of energy conversion, transfer and utilization, AC is the winner. So that is why electrical people power level, this is their best waveform. Electronic people at signal level, this is the best waveform. Okay, that is the simple reason. Now, why there are so many other reasons? Machines teachers and power systems teachers will excellently tell you, but the commercial reason is the best waveform with which we can generate and transport our energy, where all our major components like generator, transformer, transmission line, motors, induction motors give highest efficiency and power factor is only by sinusoid. Now you may ask, sir, why can't we run our motors with these things? If you run our induction motors with these things, it will run. Because our induction motor is robust, it is robust, okay. Our induction motors will run with this, nothing wrong. But what happens if you give such waveforms? Non-linear operation will come, core will go into saturation, impulses will come, saturation will come, spikes will come, parabolic nature, not smooth rotating torque won't come. Here sinusoid, smooth rotating torque. Here all pulses, torque pulses will come. And when you expand this with Fourier series, lot of harmonics will come. It will create more losses, electromagnetic interference, noise, yes or no? All these are the disadvantages. So that is why, sir, this is only number one AC waveform. If you give this only, best performance will come. If you give this, yes, it may work. No doubt it may work. Our induction motor of fan, it will run with this. But pulsating torque, harmonics, more losses, excess heat, all these are the disadvantages. That means in terms of utilization and conversion, worst waveform at power level, best waveform at power level. So the second part of my subject is AC steady state. Okay, now in general radians like 0, pi, 2 pi, okay, omega t in radians. Okay, now when I give this to our elements, how they behave? Again, resistor is an in-phase element which exhibits unity power factor. In-phase element I call. That means in resistor, sinusoidal voltage will give sinusoidal current. There is no phase shift between voltage and current. Sinusoidal voltage will give sinusoidal current, and there is no phase shift between voltage and current. Okay, it is called in-phase element. Okay, it exhibits real power, etc. Then what about inductor? Inductor exhibits reactance. Now inductor is not short circuit. Inductor exhibits reactance. Reactance is AC resistance, and here in a pure inductor, yes, IL lag VL. IL lags VL by phase shift of 90. All this we will learn mathematically, sir. See, in this 1 hour, my intention is to tell about my subject, which areas to study, how to study, and some sample gate bits and IES bits. But this, in my class, I will derive to my students how mathematically it is coming and how to understand. Then capacitor also in this chapter, when I give sinusoidal excitation, it exhibits capacitive reactance. It exhibits capacitive reactance, where again here, yes, again here, IC leads VC by phase shift phi 90 degrees. Okay, so I say resistor is an in-phase element independent of frequency ideally. Capacitor exhibits, inductor exhibits reactance, lagging element where current lags voltage by 90 degrees in phase. Capacitor also exhibits reactance, which is AC resistance, and current leads voltage by 90. Okay, that is the meaning. So then all AC phasor analysis will come. Now here to understand this, sir, we do phasor analysis. Very, very important. Today I will take such problem to tell you what is phasor, okay? Phasor analysis we do, and J is an operator, okay? J is an operator, not I. We use J operator, plus J XL minus J XC. J is a max operator. It is not called imaginary, please. There is nothing like imaginary. We are learning real existing thing. Okay, that is the second part. So, first part ideal DC number 1 at signal level. Resistive networks only will come. And the second part is ideal AC sinusoidal. Well, all are working. Okay, complex algebra like it look, but phasor analysis we call. And this is a small chapter on time variance. So, after doing two important study states, DC and AC study state, 80% of the subject, 80% of the marks are done, sir. So, if suppose 10 marks are coming in GENCO or IES or GATE, 8 marks come from DC AC, theorems, power calculations, methods of analysis, reduction techniques, etc., etc. Then the last part is, yes, transients and miscellaneous topics. Okay, electrical transients. Now what is this? This is dynamic behavior. These two are called steady state, settled state. Okay, this is DC settled state, steady state. This is AC settled state. That means here we will never talk when the circuit has been turned on, how the system is reaching steady state. Is it under damped or over damped? What is the order? What is the time constant? That questions we will not put. So in DC and AC steady state, we assume that transient is already over, on or off process is already over, and steady state we are discussing. But in this chapter, we are going to discuss about how it is starting, what way it is going, is the network stable or unstable, okay, how to make it to respond faster, all this is the concept. So this is called electrical transients. Transients is nothing but dynamic response, okay, dynamic response. So there is a network, I will show a source is suddenly turning on it. I will show a source is turning on it, okay. If it is a DC source, DC transients. If it is AC source, AC transient, okay. So like source turning on. That is why here in this chapter, we need to know the order of circuit. We need to know the initial conditions. We need to know the time constant, okay. We need to know the time constant. And then attach the steady state, complete solution will come. So after doing all this, total response will come, okay. Total response is steady state response, okay, plus natural response which leads to transients. That is how we will do. So this transient part we will concentrate. So this is the third part. Very interesting, sir. Here differential equations will come and Laplace transforms will come as the order of the network increases. DC is what, sir? Algebraic equations. Only register na, sir. Mesh and nodal are like normal algebraic equations, okay. Then AC steady state phasor analysis, J operator, phasor analysis will come, okay. Then here differential equations, exact equations will come, but as the order of the network increases, okay, then we need to go for Laplace transforms for more comfort and mathematical advantage. So that is how, sir. Yes. So the three parts. So my subject is like three parts: DC steady state, AC steady state, and transient. And of course, you have to be good in maths. That is what I would say. See, don't feel that array transient is tough. The reason you are feeling tough because you are not applying maths. In our BTech curriculum also, sir, unfortunately, in any semester, by the time we come to 7th, 8th chapter where transients exist, you people don't attend classes. Yes or no? You don't take it serious. But in fact, transient analysis is more challenging than steady state. Okay? But marks wise, this is 10% to 20%. Don't worry much. But still, competition exists here only. Easy, everyone will write. But to beat competition, you have to be good and strong in the challenging areas. Okay? So that way, yes. Then these are some miscellaneous topics. So after DC, AC, steady state and transient analysis or dynamic response, we have the miscellaneous topics. Now two-port networks. This is about mathematical modeling at network level. Networks in series, networks, not elements in series, elements in parallel. In all steady states, elements in parallel, current division, elements in series, voltage division. But here networks in series, Z parameters can be added. Networks in parallel, Y parameters can be added. So network level we do. Okay. Then network topology or graph theory. Okay. Now, sir, here and there bits are coming. Of course, in IES, I give lot of weightage to it. Gate, very rare. But studying the basic topological definitions is enough here. Then duals and duality. This chapter does not have any weightage. Frankly speaking, no weightage. I don't give any marks. But these concepts are important to learn so many things. Like series and parallel resonance, dual duality I will teach. Electric circuit versus magnetic circuit, dual duality I will teach. Then locus diagrams. Okay, network functions and patterns. Now this is there only for IES, please. That too for ECE students. It is not there for electrical. Like that, because frequency domain is more important for ECE. Then three-phase is exclusive for EEE. This is special for EEE. This is special for ECE only in IES. Okay, and this is very rare. I don't give any weightage, but this is important to understand some more concepts. And these two are default. So that way, these are all miscellaneous topics. Now and then they come. Of course, two-pairs is very important. And remaining now and then they come, sir. Okay, but electrical also, this is very important for you. Okay, that is how I would like to say DC steady state, signal level number one waveform, AC steady state number one at power level, and yes, miscellaneous signals, basic of time variance, and then dynamic response transient, plus special topics. Now, what is the importance of electrical energy? Okay, before I go, yes, I am starting my subject now. What is the importance of electrical energy? Okay, yes, electrical energy is superior form of energy when compared to so many other energies: light energy, heat energy, sound energy, mechanical, pneumatic, hydraulic, kinetic, potential. But I would like to say this energy is superior and dominating compared to all the forms because of two reasons. One is interconvertibility. And second is transportation. Yes, sir, transportation. So, why electrical energy is number one? Because of interconvertibility and what is interconvertibility? We can convert many forms of energy into electrical, then we can transport and distribution, we can convert back. Now tell me, thermal plants, okay? Boil water, steam and turbine rotate. Hydel plant, directly water is, rotating the turbines, okay? Then gas plants, directly hot gases are coming. So, wind energy, solar, okay, directly sun rays. So, we can generate electrical from many sources, okay? Many sources are tidal, nuclear, gas, biomass. So many are the resources. The beauty of this energy is interconvertibility. We can convert from different forms of energy into one common platform. Then we can transport and distribute and again convert back. Now, everywhere in our house also we are converting into different forms or not? We can generate from different forms. We can also convert into different forms. In your house, see, everything runs with electrical. Television electrical, heater, motor, today all induction heater, motor, light, fan, wind energy, ACs and fans are blowing fresh air, light energy, artificial sun are our lights. So that way, the beauty of this energy is interconvertibility. We can convert many forms of energy into one common platform and we can convert them back. That is the ultimate reason why this is superior. Then transportation. The only energy where you can transport in bulk level long distances with minimum losses and highest efficiency is electrical. And of course, I require medium of transmission, that is our conductors. T and D lines are required. Yes, at power level we require T and D lines. Yes or no? Signal level wireless, that is different. So the beauty of this energy is we can transport at bulk level long distance. We can transport at a bulk level, that too long distance. Okay, and with highest efficiency and minimum losses. Of course, we require transmission and distribution lines. That is another reason. Can you transport heat energy from one place to another place? You may say, sir, flask is there. Flask, how much it can hold? And that too maximum 8 hours, 10 hours. After that, it will become cool. Na? So no energy can do that. Okay, suppose wind energy is blowing in Tirupati. Tirupati is a hill station. Okay, Lord Venkateshwara. Their wind is there. But in Hyderabad, I want wind. How can it come, sir? You cannot do that. But I will put a windmill, convert wind to electrical. I will step up high voltage, low current, minimum losses. And again, I will step down and put a fan and AC here. So that is the wind here will be blowing here. The medium is electrical and transportation. So these are the two reasons why as ECE or EEE or instrumentation we should be proud of. Because our energy is special because of these two reasons. Then, yes, we are learning this energy both at power level and signal level. Yes, this electrical energy, we are learning both at power level and signal level. One is power level, yes, power level and signal level. Power level and signal level. Now, these electrical people learn this at power level. ECE and instrumentation, sensor technology, etc. Okay, yes, ECE and EEE people, you are learning at signal level, mostly. So this energy is superior, I told the reason, and we are learning this energy both at power level and signal level. As a network theory teacher or circuit, for me both are equal branches, or all three branches are one and the same. I told now, sir, whether it is EEE or ECE or instrumentation, I call you as Department of Electrical Sciences. Only difference is EEE people learn this at power level, ECE people learn this energy at signal level. Now what are the core subjects for EEE people? Power level. Power level means, yes, high voltage, like volts to kilovolts. Okay, high current, amps to kiloamperes. Okay, high power, watts to kilowatts and megawatts. I would say kilowatts, megawatts. Okay, I would prefer to say kilowatts, megawatts. Yes or no? But frequency in power system is always constant at 50 Hz. So electrical people learn their applications at power level. High voltage, high current, high power, but fixed frequency. Power system frequency is fixed. On the other hand, EC people learn at signal level. Signal level is low level. That is low voltage, like microvolts to few millivolts, okay, or hardly few volts, okay. Then low current, microampere range to milliampere range. Okay, then low power, milliwatt to hardly few watts, but their frequency of communication and signal processing is kilohertz, megahertz, or even gigahertz. That is high frequency, because they have narrow band, wide band, audio signal, video signal, okay, communication signal, so many things they have. So see the big difference. Please understand the difference. Electrical people learn this energy at power level, high voltage, high current, high power, but fixed frequency. ECE learn at signal level, low voltage, low current, low power, but frequency is wide range. Okay, they have wide range. Okay, data communication they are doing now, sir. Audio range, video range, radio range, like so many things. Airtel has a bandwidth, Vodafone has a bandwidth, Tata Sky has a bandwidth, Tata Sports Channel has a bandwidth, like that. So yes, both are learning same energy, but power level versus signal level. So that is why, what are the core subjects for electrical? The core subjects for electrical are power electronics, power systems, electrical machines. They are all power level. What are the core subjects for electronic people? Signals and systems, analog, digital, microprocessor. So for them, these are the core subjects, and for them, power level. Now, because of this difference, yes, because of this difference between signal level versus power level, the performance analysis of both the applications are different. Like electrical people, because they are dealing at power level, for them what are important? What are important? Yes, percentage efficiency, cost factors, power factor, voltage regulation, losses, safety, okay, safety, protection, reliability, etc., etc. I'm not writing neatly, but understand. So because electrical people are dealing at power level, what parameters affect their design, or what are the performance parameter at power level? Cost, because it is costly at high level, sir. Today you see the tender cost of 1 megawatt generation and transmission is more than 17 crores. Huge cost at megawatt level, gigawatt level. So don't underestimate, sir. So at power level, that is very expensive. Okay? Yes. And efficiency is important, power factor is important, voltage regulation should be minimum, losses should be minimum, safety, high voltage, high current, now sir, you have to be very safe, protection, reliability, etc. are the design factors. That are the design factors. On the other hand, ECE people, because you are learning at signal level, low level, for you efficiency and power factor is not important, because you are talking milliwatts to few watts. Their efficiency and power factor is not important. But what you talk, yes, you talk precision, accuracy, portable, compact, speed, yes or no, speed, okay, then automation, intelligent control, AIC I write, sir, but automatic, intelligent and control, okay. So EC people, your products, yes, EC people, your applications, your products, because they are at signal level, here we are not talking about money much, signal level is a low level, but yes, what are the design parameters for your components or your applications? Precision, accuracy, portable, compact, speed, automation, intelligent control. Now I'll give an example. In my house also, I'm utilizing this energy both at power level and signal level. Now every month I pay my energy meter bill, somewhere 2,000 to 3,000 rupees. That is kilowatt hour meter. Our energy meter is in a kilowatt hour meter. That is for utilizing at power level. At the same time, I pay my Airtel bill, Tata Sky bill. Okay, I also pay my Act Fiber or Geo Fiber. That is all signal level. So that means in our house also, the same electrical energy, power level, okay, energy meter, signal level, data communication, Airtel, all this. So we are using energy both at power level, signal level. So for electrical people, their T&D lines are our lines. For EC people, their fiber optic communication, okay, wireless systems are their transmission lines concept. So yes, power level versus signal level. Example, air conditioner versus cell phone. If you buy air conditioner, what you see, sir? Air conditioner is a power level product. A 2-ton AC is like 2 kilowatt, approximately. A 2-ton AC is like 2 kilowatt. What we see? Power factor, efficiency, how safety it is, inbuilt voltage regulator is there, inverter technology, that is what we see. But when you buy a cell phone, will you ask the manager there, give me a cell phone which is efficient? No, you will say, I need more RAM, speed, okay, I need it to be compact, portable, smart, intelligent, all the tools, okay, the more space. So that is the difference. So buying an air conditioner versus buying a mobile phone, there is a big difference. Mobile phone is signal level, air conditioner is a power level. Okay, that is a simple meaning. Now comes the story. Is really learning electrical electronics engineering difficult? Is really learning electrical? Yes, sir. They say electrical engineering is tough. I don't know, like society feels that. Okay, we are all engineers, and the person who know about it should not talk this way. But they say, okay, electrical professors are sadist. That is what they say, na, electrical professors are sadist. What sadism, sir? No sadism. There is nothing sadism. We follow rules. That rules are like Ohm's law, Kirchhoff law, Biot-Savart law, Fleming left-hand rule, Fleming right-hand rule. We need to be very, very careful in applying, and we need to be careful with this energy at power level. That is not called as sadism. So they say electrical professors are electrical department is tough. No, it is not about electrical department being tough. We should be careful, and there is a procedure to solve it, and that procedures are calling us as sadist is very bad. So electrical engineering is not tough, it is challenging. But there is some reason why everyone say there is difficulty in understanding. Compared to computer science, civil, mechanical, chemical, they say electrical engineering is tough. And one of the reason is, in understanding this great energy, yes, in understanding this great energy, all our 5 senses fail. That is the thing I would like to claim. If you ask me, sir, if there is some difficulty in electrical science, what is it? This is the difficulty. In understanding this great energy, all our senses fail. God gave us 5 senses. Panchendriya we call. Yes or no? What are the 5 senses? Yes, sense of touch, sense of vision, sense of smell, sense of taste, and sense of hearing. Nothing will work in electrical. The beauty is nothing will work. Can you taste DC voltage, AC voltage? Tell me the difference. Can you do that? Can you taste it? What you will feel? Nothing. Can you see flux and charge? See, there is so much of flux and charge around us, sir. So much. But we cannot see. That is why, sir, EMF is challenging to learn. Sir, we need to learn vector calculus. Okay? Yes. Now, what is this angle? Everybody tell me, what is this angle? Mechanically, it is 90 degrees, right? Mechanically, 90 degrees. There is a protractor. In my subject, current lags voltage by 30 degrees. Show me. Can you see? That is the difference. So, if you claim, yes, electrical engineering tough, it is not tough, but it is challenging to learn because of this reason. Because in understanding this great energy, our 5 senses don't support us. Okay, mechanical torque. Suppose mechanical people, mechanical engineering, they are very lucky. Mechanical torque, I can push him. Linear torque, I can rotate him. Rotational torque. But the electrical torque, how to understand, sir? You cannot understand electrical torque like motor. Only motor can understand, because you are not a conductor like aluminum wire or a copper wire. Only aluminum or copper conductors can understand electrical torque, because you cannot respond to that. Mechanical torque, I can understand. Put on a scooter and put first gear, you will experience torque. But electrical torque, the only way to learn, yes, then the only way to learn is mathematics. So if electrical engineering is challenging, then how to learn? We can still learn by using mathematics, and second is notations. Okay, and these notations are very strict rules. Like when I do mesh analysis, go clockwise, I will tell. Okay, that is a notation I am following. When I write nodal analysis, take current leaving the node as positive, current entering the node as negative. That is the notation. And we should be very good in maths. Okay, linear algebra, matrices, Laplace transform, differential equation, integral differential equations, higher order circuits. Okay, EMF, why you are feeling tough? Because you don't know vector calculus. Yes or no? You don't know vector calculus, you are feeling EMF is tough. But if you know vector calculus, you will enjoy it. Why signals and systems, some students feel very, very complex? Because you are not understanding Z transform, you are not understanding Fourier transform. So, electrical engineering is not tough, sir. Electrical engineering is a great energy. We can learn, but of course our senses are not supporting, but we can still learn with maths and notations. That is the thing. Okay? That is about my subject. Then, yes, this is a quick review I want to now talk. Now let us be very serious, sir. So far what I gave, okay, is all about my subject, concepts, etc. But now, what are the things coming up? Now this area I will go briefly, but accurate data accumulated, which was very, very hard work I did, sir, to make these slides. You pause it and read carefully, but I will go very briefly, because any exam, like most of the exams in India, whether you write GATE or IES or GENCO, there are 4 types of questions. Okay, there are 4 types of questions. Okay, recall, comprehension, application, analysis and synthesis. Okay, what is this? I gave the comments there. But always remember, any competitive exams like GATE, IES, GENCO, there are 4 types of questions. Okay, recall, comprehension, application, analysis. I wrote the comments, please read it. Then in that again, after taking that one of that question, either comprehension or application analysis, in GATE they are modeling either as MCQ, NAT or MSQ. What they are doing in GATE, they model either as MCQ, multiple choice question, NAT, numerical analysis type, MSQ, multiple select, beautiful concept, sir. Multiple answers will be there. Then, yes, briefly I will read. Let us not go in detail. Yes, what is this MCQ? Multiple choice question carry 1 or 2 marks each in all the papers and sections. These questions are objective nature and each will have the choice of 4 answers, out of which only 1 is correct. Native marking, etc. I wrote here. Please read carefully. Pause it and read. Okay? Please pause it and read. Okay? Then, how to score more, I gave some suggestions. How to score more, where to be careful, etc. Okay? Let us not go in detail because this you should read. Okay? That I want to give the details very carefully. NAT, it is called numerical answer type. Numerical answer type questions carry 1 or 2 marks, which in most of the papers and sections for those questions, the answers is signed real number, which needs to be entered by the candidate using virtual numeric keypad. Virtual calculator is there now in GATE, or the monitor or keypad of the computer will be disabled. Okay, keyboard of the computer will be disabled. Okay, sir. Here he will mention the range. Up to 2 decimal places, up to 3 decimal places. Beautiful. Why such things are given in GATE? Because you want to differentiate between a quality student and a student who is just coming by luck. There is no luck here. You cannot have luck in GATE. If you prepare properly, you will get rank. If you don't prepare, nothing. Because accuracy up to 3 decimal, 2 decimal places he is asking, sir. You cannot copy, nothing like that. So that is the meaning. Okay, numerical answers are always challenging. Then I gave again suggestion how to get more score, what to do. Okay, all this I gave. Please read it. Okay, go through it. Pause the video and read it. I did a lot of effort to accumulate this idea, sir. Then third type is MSQ, multiple select questions. Multiple select questions carry 1 or 2 marks in each or all the paper sections. These questions are objective in nature and each will have choice of 4 answers, out of which 1 or more than 1 choice are correct. Only 1 bit or 2 bit or 3 bit, all the above, like that. So, but remember, native marking is there especially in MCQ only. MCQ only. In numerical and in MSQ, there is no native marking. But however, if you are not thoroughly ticking all the options, you will not get any marks. If you tick only 1 option, suppose 3 options are there, you tick only 1, you may not get marks. If you tick all 3, then only you will get marks. Native marking is not there in MSQ and NAT, that you remember. But native marking is there only in MCQ, that you remember. Okay, so this I gave some suggestions again in MSQ also. Okay, then let us take this question. Now this is where I want to share. Sir, in 1 hour, yes, it is not a magic to teach everything. In my regular class, sir, around 70 hours or even plus 70 plus hours I take to teach the entire subject. But here I am giving the overall view about my subject and what sort of preparation strategy and what sort of questions can be expected. Now, sir, again, though I say this area some questions came, but in such competitive exam, nothing is like important or unimportant. Balance all, yes, balance all, but still guidelines, do the things which are dominating concept-wise and quantity-wise, but don't leave any topic. Because in competitive exam, it is not about getting 60 marks or 70 marks. If paper is easy, then cutoff in GENCO will be 85 out of 100. Imagine, scoring 85 and only will get a job. 84 marks student also will not get job. So it is all about beating the competition. So everything is important. Okay, chalo, with all this so much of data which is so important according to me, this questions is to encourage you, but in 1 hour I cannot do any wonder and magic, sir. We will have more sessions. No doubt, sir, we will have more sessions and more, chapter-wise per hour also I am planning to discuss with you. But here main intention is to show the difference. Now see, I am taking one GATE question, 2 marks, which is MCQ. Okay, this question is MCQ. That means multiple choice question. Out of this, 1 is only correct. Okay, now see this. He gave an infinite ladder. Okay, sir, it is an impedance. Yes, everybody, you observe now, it is an infinite ladder. okay, where the series arms are inductive reactance plus JXL given, and in shunt arms, inductor and capacitor are in series. Inductor plus J 6 ohms, J is operator, and capacitor is minus J 2 ohms. So series arms are inductor, shunt parallel arms are L and C in series. And is asking total impedance, and it is infinity. It is going up to infinity. Now this is a mathematical modeling question, sir. That means actually here inductors, capacitors are there, but is exciting this with a sinusoidal voltage or some function at some frequency. It is understood that these are inductors, capacitors excited by some sinusoidal supply at a fixed frequency, then only this reactance will come. But is asking impedance seen between these two elements in an infinite ladder. Now in mathematics we know, sir, infinity is such a large number that infinity plus and minus is infinity. So what I will do, yes, very carefully watch this. Yes, what I will do, yes, if this is my target terminals where I want Z, even you remove one segment, this is also Z, this is also Z, because infinity minus 1 is infinity. If this is total Z, okay, because infinity is such a large number, you add or remove anything, it is infinity. Infinity plus 100 is infinity. Infinity minus 1000 is infinity, like that. So if this is an infinite ladder, you know this is the pattern repeating. Okay, this is the periodic pattern. This segment repeats. This segment. So this L section keeps repeating. Now what I can do, if this is infinite ladder, whose Z I want, even if I remove one segment, some periodic segment, this is also in Z only. Because infinity minus 1 is infinity. Like if this is Z, remove this segment, this also will be Z. So I will lump this first into Z, lump it, group it. That is the mathematical modeling. Of course, lumped parameters are not accurate, but approximate. This is a mathematical modeling question. Chalo, if this is Z, remove one segment, this is also Z. So I will lump it. Then that Z in parallel to this plus this is also Z. So if I model this now, chalo, if I model this now, yes, what it is coming now? Yes, this is the same thing I am writing now. This is Z again. This is Z again. Okay? This is J9, this is J6 minus J2, and this is Z, and this total is also Z. So this is the approximate. Why I will say approximate? Because lumped parameters, yes, lumped parameters approximate. So here, yes, infinity minus 1 is infinity, then infinity plus 1 is also infinity. So what I did logically, I removed one segment, I lumped it and I added back. That is the concept. I removed one segment, periodic segment, I lumped it. Lumping is approximation. Then added back. The reason, infinity minus 1 is infinity. If this is Z, remove 1, this is Z. Chalo, over. Now this is the thing I should solve now. Chalo, if I solve it, now be careful, sir. Calculations are very important. This Z is J9 plus, these two are in series, J6 minus J2 is J4. J4 is in parallel to Z. So Z is J9 plus, this is this into this, J4Z by Z plus J4. Okay, cross multiply, Z square plus J4Z is equal to J9Z minus 36 plus J4Z. Because J square is how much? J is 1 angle 90. J square is 1 angle 180. 1 angle 180 is minus 9 4s are 36. That is J operator. Don't say it is root minus 1. That is not the meaning. Chalo, now if I remove this, okay, then I will write Z square minus J9Z minus 36 is 0. Chalo, let us solve this, everybody. So I am solving this quadratic equation. Minus B. So finally Z is minus B means J6 will come. Plus and minus root of B square. If you do B square, minus 81. Minus 4AB. B minus 4AC. C is minus 30. This is plus 30. Okay. Minus 4AC by 2A. Okay. This you see, sir, plus 36 will come here. Okay. So minus 4AC by 2A. 2 into 1. Because we are solving for Z and J is operator. So minus B plus and minus root of B square, because minus minus plus J square is minus 1, minus 81 minus 4AC by 2A. So now if you observe, everybody, this is J6 plus and minus root, this is 14481 is minus 225 by 2. That is again J6 plus and minus. Now root minus 225 is J15 by 2. Chalo, sir, now very interesting. Now, sir, listen carefully. If you take plus 6 plus 15, okay, yes, it is coming now, yeah, I can say it is 9, J9 actually, okay, 9, let me correct it. It is now 9 plus 15, Z will be almost J24 by 2, J12. But if you take minus, or if you take minus, 9 minus 15 is minus 6 by 2, it is minus J3. Here, sir, everybody listen. A square, ax square plus bx plus c. What is b? Minus j9. So minus b is how much? Plus j9. Okay, that I forgot. Plus j9. So minus b plus and minus root of b square minus 4ac by 2a. So this will be plus j9. So I will write neatly here j9 plus n minus j15 by 2. Okay, chalo. You check it, sir. No problem. Then now c is here. If I take plus 24 by 2, 12. If I take minus 9 minus 15 minus 6 by 2, minus 3. Okay, that means you see very carefully. Two possible answers came. You see now, very interesting in gate. So plus j12 is there, minus j3 is there. So many may think, sir, it is MSQ. Cunning, na sir, cunning. But I don't say this is MSQ, this is MCQ only. Can anyone tell me why? Can anyone tell me why? What would be the correct answer? Though both answers came mathematically, but application and concept wise, you cannot select both here. How much cunning bit it is. So many may say, sir, both are technically correct. Positive reactance inductive, negative reactance capacitive. So I will tick both. It could be MSQ. No, no, no. Why? Because you see the nature. Sir, here all series branches are inductive. All series branches are inductive. And in shunt branch also, XL is greater than XC. XL is greater than XC. So shunt branch also, which is dominating, inductive. Array, when series branches are inductive and in shunt branch also it is inductive, overall nature is inductive. Overall nature of the network is inductive. It cannot be capacitive, sir. It cannot be capacitive. That is why this is not correct. Though mathematics gave, technically or physically it is not correct. So answer is only J12. Answer is only J12. See how good it is. So many students will be tempted to write both, thinking it is MSQ, multi-select question. But no, sir. The reason, though mathematically we got both answers after careful calculation, both are technically right, like positive reactance, inductive, capacitive, negative reactance. But see, nature of the network is inductive, sir. All series elements, positive reactance. Shunt also, XL greater than XC, positive reactance. So nature of the network is inductive, plus J12 only. Understood? See how good question it is. Then, this is NAT. Now this question he asked, yes, to give up to 2 decimal places accuracy. It is an integer generally, but 2 decimal places accuracy also is expecting. What is the question is asking? Yes, listen now. The impedance looking at nodes 1 and 2 is dash. The impedance looking at node 1 and 2. Now, sir, the problem here is there is a current dependent current source. Now, dependent sources will have some internal sub-circuit resistance which we should consider. Dependent sources have internal sub-circuit resistance. If it is an independent voltage source, zero resistance. If it is an independent current source, infinite resistance. We can open it. But this is a dependent source. What type of dependent source? Current dependent current source. And where we will find this? In our transistor circuit, op-amp circuits, analog circuits. We model them, na? So, like current dependent current source is a BJT example. A BJT is a current controlled current source. Like that. So, it could be an application from analog. But in my network theory is asking to find the impedance looking between node 1 and 2. Now here reduction directly not possible. Though this branch and this branch are parallel, but there is a dependent source. We should include its internal resistance. Then what we do? Reduction not possible. So let us apply Ohm's law. So what I will do? I will apply Ohm's law. What is Ohm's law? Give voltage, find current. Or give current, find voltage. Ratio of V by I is R. But it is a numerical type, sir. Be careful. Chalo, what I will do now, everybody? Let me inject 1 volt. And I will find I total, because we are finding resistance between 1 and 2. Because we are finding resistance between 1 and 2, I gave voltage between 1 and 2, and I want current released by this 1. Then what is R12? That means resistance between 1 and 2 is 1 volt by I total. I need 1 volt by I total. That is what I want. 1 volt by I total. Chalo. Now to find I total, I will write a KCL here. To write a I total, I will write a KCL here. But to write a KCL, let us find the remaining currents. Yes, everybody. When 1 volt is given to 100, this is 1 by 100. Same 1 volt is given to 10K. See, this is 1 plus 9, 10K. When 1 volt is given to 10K, this is clearly 1 by 10K amperes. That is 0.1 milliampere. But you know, in a passive element, current always flow from high potential to low potential. So when this is plus and this is minus, current flow from high potential to low potential. But his given reference and practical directions are opposite now. So IB is automatically how much? Practical direction is going like this, but IB is going ulta. So IB is minus 1 by 10K. Now when IB is minus 1 by 10K, there is a current dependent current source. It is 99 IB. So when IB is minus 1 by 10K, this is minus 99 by 10K. Minus 99 by 10K down means, this way, okay, anti-clock means 99 by 10K clock. Chalo sir, nothing I did. Everybody, first of all, this problem is unique, numerical analysis type, and here dependent source is given. If only resistors are there in series, parallel, star, delta, I would have done, but dependent source. And dependent source will have internal sub-circuit resistance, we should include. So Ohm's law I kept. Give voltage, find current. So I gave 1 volt, test voltage 1 volt. You may say, sir, why you took 1 volt? Why can't 100 volts, 1000 volts? Anything you take, your lucky number also, answer will come. Because V by I ratio is R. So I took 1 volt and I want I total. This is 1 by 100, this is 1 by 10K, but IB is minus 1 by 10K, so this is minus 99 by 10K. Minus 99 by 10K going down this way means 99 by 10K going down. So now I am writing the KCL. Okay, what is the KCL, everybody? Yes, tell me the KCL, everybody now. Incoming currents equal to outgoing currents. Incoming I total is equal to outgoing. One is 1 by 100 plus 1 is 1 by 10K, and this is 99 by 10K practical direction. Okay, so if I write a KCL, incoming is equal to outgoing. Incoming I total, outgoing 1 by 100, 1 by 10K, 99 by 10K. Chalo, if I simplify, I total is 1 by 100. Here take again 1 by 10K common. So this is 1 plus 99, another 100. So 100 by 10K is another 1 by 100. 1 by 100, 1 by 100 is 2 by 100. 2 by 100 is nothing but 1 by 50. So now I will write R12 is 1 volt by I total. 1 volt by I total, how much you are getting after solving, sir? Get always max. Solving is important. Previous problem also see. Solving, even I substituted wrong there. So solving mathematics will be very important, but be careful. So here also see calculations. So I total is 1 by 50. So 1 by 50 is 50 ohms. 50.00. That is the meaning. Numerical. Okay. So this is one model. First model, MCQ model. Though we got 2, but they based on the practical concept. That is what intelligent you have to be. Don't tick both. Meaningless. All the nature is inductive, so answer is this one. Okay, it tends to be MSQ. Then this is numerical. Then what is the third model I was talking? MSQ, multiple select. This is one of the beautiful problems. MSQ bit I am doing now. Everybody watch this. This is a problem from AC steady state. First problem is an impedance concept, that is also AC steady state. Second problem is a pure DC but dependent source model. Now this problem is again AC steady state, but see here. There is a sinusoidal source of 15 volts. Without mentioning anything, just voltage given means it is RMS value. Yes or no? Without mentioning anything, just given AC voltage RMS. If I say function like Vm sin omega t, then that becomes maximum. But otherwise, this is RMS supply voltage, which is how much? 15 volts. And sinusoidal symbol means AC. Then he told these two voltmeters are reading 20 volts and 9 volts. Voltmeter V1 is reading 20 volts, V2 is reading 9 volts. Now voltage across capacitor alone is asking. You want voltage across capacitor and he gave 4 options. Okay. Now the complexity in this problem is he did not give individual element voltages. He gave combination. Yes, the problem here is he did not give individual. He gave combination. Like between R and L together he gave. Between L and C together he gave. If individual voltages he gave depending upon which is greater, which is smaller, I would have assessed the network. Because in AC circuits, if it is an RLC circuit, the circuit can behave in 3 ways. In AC circuit, if it is an RLC circuit, the circuit can behave in 3 possible ways generally. If XL greater than XC, lagging power factor, inductive nature. If XC greater than XL, leading power factor, capacitive nature. And if XL equal to XC, net reactance 0, purely resistor. That is a resonance condition. So AC circuits can behave in 3 possible ways. Either RL nature, XL greater than XC, or RC nature, XC greater than XL, or purely resistance if XL equal to XC. Like in our house, AC circuit, it is dominant with inductor. In our house, what is the nature, you may say? Our power in our house is AC power, alternating. Okay, DC is remote, I told you, sir. Very few applications are DC. Of course, there are more applications, but power coming from state electricity board is AC, alternating current we say. Then your house is what? Generally inductive. Why? Because dominate inductive because our motors, fans, pumps, they are all coils. So at power level, inductor dominates. Power level, inductor dominates. So that is inductive. But here we don't know. We don't know, depending on, and that to combination he gave. Generally what happened? Yes, because it is a AC steady state, thinking at power level, 99% of the students assumed first lagging power factor. So what they did? So first they assumed lagging power factor, means XL greater than XC. Inductive reactance greater than capacitive reactance. One thing, it cannot be unity power factor because if XL equal to XC, these two are equal and opposite forces, then this voltage should be 0. Na? If XL equal to XC, equal but opposite forces, phasor sum of voltage would have been 0. If V2 is 0, then only I would have said it is purely resistive case. But V2 is given. V2 is given. So unity power factor case is ruled out. Out of 3 cases, unity power factor case is ruled out because this voltage is given. Remaining 2 cases can exist. But most of the students, what they did, array, this is generally AC steady state, inductive dominant, so they assume directly lagging power factor. Lagging power factor means, yes, XL is greater than XC. So automatically VL will be greater than VC. But these are voltmeter readings. Elemental values it did not give. So what we should do? Phasor diagram. So let us draw the phasor. But in a series circuit, I will take current as reference. So let me take current as reference. Now with respect to current, which voltage will be in phase? Resistor voltage is in phase. Okay? Resistor voltage is in phase. What about the voltage in a pure inductor? In a pure inductor, current lags or voltage will lead. Voltage will lead current. But clearly when XL is greater than XC, VL is greater. So I will take this as greater. Okay? Then what about a pure capacitor? In a capacitor, current leads, voltage lags. Voltage lags. But clearly XC is small. So VC also should be small. VC also should be small. That is the meaning. So in lagging power factor, VR is in phase. VL leads I and VC lags I by 90. But importantly, because it is XL greater than XC, VL should be greater than VC. Okay? So now let us substitute the data given. Everybody watch this. Let us substitute the data given. Now here, total voltage between R and L is voltmeter V1 20 volts. That is phasor sum of VR plus VL is 20 volts. VR, VL, phasor sum is how much he gave? 20 volts. Okay, 20 volts. Then what he gave? V2 reading, phasor sum of VL VC is 9 volts. Phasor sum of VL VC is 9 volts. So VL VC, adding to opposite forces means subtracting only. So this if you remove, this much will come. Okay, this much length you remove, subtract here. And this will be 9 volts. This will be like 9 volts because VL VC is voltmeter reading. VL plus VC is 9. Then altogether, see altogether VR plus VL plus VC is supply 15. Okay. Chalo, if I substitute VR plus VL plus VC should be 15. But VL plus VC is already this. VL plus VC is already this. Plus VR is this, which is 15. VL plus VC is this. Plus VR is this. Chalo, now with this data, he is asking what, sir? He is asking voltage across capacitor alone. This width, this length is asking. Chalo, voltage across capacitor alone is asking. Chalo, now all Pythagoras theorem and no calculator. Chalo, now see here. This is 15, this is 9. So this length has to be how much? Root of 15 square minus 9 square. 225 minus 81 is 144. So 12. Root 144 is 12. Root 144 is 12. Now if this is 20, this is 12. Yes, if this is 20, this is 12. This has to be how much? This has to be 16. This is 16, 9, this is 7. So this length is also 7 because this we subtracted here. Na? So in this right angle triangle, this is 12. In this right angle triangle, this is 16. And if this is 9 and 16, this is 7. So this length has to be 7. So one answer we got. So what happened? All the students thought it is 7. All the students thought it is 7. But what happened? Now see, very interesting. All the students thought it is 7. Okay. But it is an MSQ, you have to be intelligent. Now the student who is intelligent and who is more careful, he went to assumption of leading power factor also, leading power factor. In leading power factor, XC is greater than XL. XC is greater than XL. Okay, what is doing XC? So again sir, if I take, yes, current is reference, VR is in phase. Okay, VL will lead I, but it is small. VC will lag I, but it is large. Okay, this is also possible na? Then again, let us substitute the data. We know that phasor sum of VR, VL is 20. This is given as 20. VL, VC. Now this time VC is larger. This if you subtract here, this if you subtract here, this is 9, this is 9 volt. Then altogether VR plus VL plus VC is supply 15. So VR plus VL plus VC. VL plus VC we got, and plus VR is, this is 15. Chalo, again he is asking what, sir? Total capacitor voltage. So that means this length we should find, put it here, and total length will come. Chalo, now if I do that, everybody, see, this is a right angle triangle, this is 15, this is 9, so this has to be 12. If this is 20, this is 12, this has to be 16. If this is 16, this width is also 16. But total VC will be 16 plus 9, 25 volts also possible. See the beauty. So the student who took XL greater than XC lagging power factor, for him 7 volts came. But a student who is more intelligent, careful, and possibility he will check, na sir. He will take leading power factor also, and he will say 25 is also possible. 25 volts is also possible. So here it is an MSQ. So both are correct answers. Both are correct answers. This will be the answer when inductive reactance dominates capacitive reactance, because no information is given. XL is greater than XC. This will be the answer when capacitive reactance dominates inductive reactance. So both are correct. So this is the meaning of MSQ. Okay. But suppose you tick only one, no marks, 0 marks. If you want marks, tick both. But if you tick this, no marks, no use. So be careful, sir. If you tick both in this case, some bits, all 3 options correct, some bits, all of the above. Sometimes only one also can come, to confuse you will give. But the beauty is, these are the 3 models, sir. That is my intention of teaching this session very carefully. What sort of level, what level will come, what is the clarity, and which areas to concentrate. That is, one is MCQ. Here, though he gave 4, see the nature, inductive dominant plus J12 only is correct. Okay. Here, here it is a numerical analysis type. It is only yes. And finally, and this you see, MSQ. Both are correct. Okay. MSQ, both are correct. That is what I would like to say. Okay. So yes, my intentions are, there are so many bits I can teach. Yes, there are so many bits I can teach. Yes. Okay. Yes, we will share a lot of data with you. Please do join. Yes, please do join ESE Engineering Academy. Okay. In 1 hour, I cannot do any magic, sir, but we are planning to have even chapter-wise discussion that we will do very soon. But please do subscribe our channel, join our institute, because I only can say, sir, we are specialists in teaching exam style. Of course, sir, your BTech teachers, respect them, they are great, and reading a textbook is always a textbook, no doubt. But here what we are trying to do, okay, how to get rank in a simpler way, accurate way, by following our material. Okay, because we are being trained by studying this, correct modulation, I could say. That is a term I would say. We are modulated to get the rank. Okay, we will mold you to get rank. And we are also having that modulation, what to teach, what not to teach, which area to concentrate, which style to attempt. Textbook is textbook, sir, no doubt. So in BTech, I request and recommend everyone, please read standard good textbooks, sir. With that fundamental knowledge, come here, join our institution. We will fine-tune you to get success in such extraordinary competitive exams where you can crack in PSUs, IES, and IES is IES, sir. Engineering service exam, hats off to all my students who achieved there, sir. That is the #1 gazetted post they get, and they enjoy the power of being a technical man. Okay, they are the, in defense, research organization, they will get scientists, and in lot of areas like ordnance factory, Indian Railways, extraordinary people, sir. So, yes. In Genco Transco also, state government, don't underestimate it. It is so cool job, you will be within your state or within your district and locally with your family, friends, and also having a lot of security and support in these government jobs. They are great, let me tell you. So please do subscribe and join our institution, and we will definitely tune you with our content and material to get that rank. But of course, I still recommend BTech. Be serious, read good, simple, standard textbooks, go regularly to college, have that basics. Then I am telling you, I will tune, or we all as a team will tune you to get very good rank. Okay, all the best. The intention of this is to share such knowledge about how to get the idea in attempting GATE and IES, okay, Genco, etc. But we will also share a lot of knowledge. So join, and I said, na sir, I will teach some minimum 70, and IES some 100 hours I will teach. You imagine that how much content I can give you if 1 hour is this lecture I can give. Okay, so all the best, and thank you for watching my lecture. ఎట్లా చెప్పినా